Hi everybody, this is Ryan. I'm here for another video. This time we're going to talk a little bit about probability. Okay, so here we go. Basic probability. Given that all outcomes are equally likely, we can compute the probability of an event using this formula. P stands for probability. So like I said, P probability of P E is the probability of the event. P's probability, E's event. It's a number of outcomes to the event E and total number of equally likely outcomes. So if we think about flipping a coin, so a coin can either be a head or a tail. So the probability of a head on two tosses would be a 1 out of 2. So that's basic probability. Probability of a success. So sometimes I call this a number of successes over the total. And that total would be successes plus failures. If you think about a dice, so if you think about a dice has 6 numbers, usually a 1, 2, 3, 4, 5, 6. So the probability of a 1 would be 1 out of 6. Probability that's even. So probability that's even would be there's 3 even numbers. There's 2, 4, and 6. So the probability that's even would be 3 out of 6, or 1/2. So at this random moment, you look at the clock and note the minutes reading. What is probability? The minutes reading is 45. So how many minutes are there in an hour? So there's 60 minutes an hour, 1 to 60. So the probability that it's exactly 45 minutes would be probability of 45 would be 1 out of 60. Probability that it's 45 or less. So that would be less than 45. The probability less than 45 would be 45 or less would be 45 out of 60, or you reduce that to, let's see, you can take a 5 out, that'd be 9 over 12. Take a 3 out, that'd be 3 over 4. So the probability of less than 45 would be 3 over 4. Okay, so here we go. Certain and impossible events. An impossible event is an event of probability 0. Examples of an impossible event would be rolling a 6 on a 4-sided die, or selecting a number greater than 100 from a set of positive whole numbers less than 10. Certain events have a probability of 1. So examples of certain events are rolling a 4 with a 4-sided die, selecting a number that is less than 100 from a set of numbers less than 100. So the probability will be between 0 and 1. So the probability can be 0, it can be all the way to 1. It can't be any more than 1. So let's talk about complement of events. The complement of an event is the event E doesn't happen. So I mentioned a little bit ago successes and failures. So you can think of the complement as, if the success is what you're looking for, the complement of a success is a failure. So E bar looks like this. That's what you usually denote a complement of E as. We can compute the probability of an event using probability of E bar as 1 minus the probability of the event. And correspondingly, probability of the event is equal to 1 minus the probability of its complement. What is the complement of the event guessing a multiple of 3 on a scale from 1 to 10? So from 1 to 10, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 numbers. So the bottom will be 10. What is the complement of guessing a multiple of 3. So the multiple of 3 would be 3, 6, and 9. So the probability of a multiple of 3 would be 3 out of 10. Its complement, or not a multiple of 3, would be 1 minus 3 over 10, or 7/10. So there's 7 of those numbers. So if you think about those, there's 1, 2, 3, 4, 5, 6, 7. So that would be its complement right here, 7/10. Probability of two independent events. Events A and B are independent if the probability of B occurring is the same whether or not event A occurs. If probability of A and B, if event A and B are independent, then the probability of A and B occurring is the probability of A and B equal to the probability of A times the probability of B. And probability of A or B is that formula is probability of A plus probability of B minus the probability of A and B occurring together. So this right here is the same as that right there. So you could rewrite that as probability of A plus probability of B minus probability of A times probability of B. Here's the question. Select two independent events that can occur during an interaction with your item. For example, if you have colored candy, this could be selecting a candy that is a warm color and selecting a candy that is red. So probability of A and B for your two events. Try solving probability of A and B for your neighbor's choice. So here we go. So probability of A is 12 over 52, or 3/13. Probability of B is 26 over 52, or 1/2. So probability of A and B would be 3/13 times 1/2, or 6/52, or 23 over 26. Now using the same two events, solve P or B. So probability of A is 3/13. Probability of B is 1/2. Probability of A and B we found to be 3/26. So to do that, you just take 3/13 plus 1/2 minus 3/26, and you get 8/13. Okay, conditional probability. The probability that event B occurs, given that A has happened, is represented by probability of B given A has occurred. And that's read as the probability of B given A. And this is given A has occurred. And here's your two formulas. You can write it two different ways. Now let's do question 5. Now we must select two events that occur across two interactions with your item. For example, if you have a die that could first roll shows a 4, and then the sum of the die is 7, solve the probability of A given B. So here we go. So probability of B would be 6 out of 36, or 1/6. Probability of A and B is 1 over 36. So to figure out this solution, you would do probability of A given B is right here. Now here's Bayes' theorem. Permutations. A permutation is an arrangement of a set of objects in a particular order. In a permutation, the order in which the objects will be arranged is important. So order matters. Order matters. So here's the formula for probability. Now this right here is n factorial. If you don't remember what n factorial is, it looks like this. So n factorial. So if I do 5 factorial, that's the same as 5 times 4 times 3 times 2 times 1, which would be equal to 20 times 6 times 1, or 120. That's the probability. That's the factorial piece. The 4 factorial is equal to 4 times 3 times 2 times 1, or 12 times 2, or 24. That's how you do permutations. The combination formula is right here, and order doesn't matter. Without regard to order, order doesn't matter with combinations, so your formula is just a little bit different. So, hope you enjoyed this video. Hope it helps. If you have questions, let me know.